Hello and what's up to you all matriculants. This is yet another great session that you're about to have with us. Time to learn more and learn extra even on this second term. I hope you enjoyed your first term and you were learning so much over the holidays, but I believe that some of you were working so hard. But my name is Abram and I'm with John today. How are you, John?
Very good, Abram. And by the way, happy birthday.
Thank you so much, sir. Really appreciate. Talking about my birthday-ish, yeah, it's fine. It's a nice day that I'm working because I feel like the more you give on your birthday, it's better than just sitting.
Better than sitting back.
Because so many people are sending you messages. I think some people just feel lazy and
they just want to take a day off.
They just want to take it
But
away.
a birthday is a good day just to get up, make some new ideas, set some goals for the new year, and let's reach for the sky.
So true, reach for the skies because it's the beginning of a new year on somebody's life. But now, did you have your holiday?
No, Abram, I didn't get. I'm going to take some time out a little later.
On your
the
birthday?
Easter, no, that's late. In Easter, over the Easter weekend, I'll probably take a few days off. So we just worked through, and I'm really excited to be back with you. And we've got a really interesting topic to do. It was part of term 1, so I know some of you are going to say, "But why are you?" No, because we didn't get to do this at the end of term 1. Remember, the Learn Extra live shows are meant to be revision of work that you've already done. So we just want to give you a chance to get into the new work for term 2. So we're not having to teach you. You can come with your questions and make sure that you're staying on track with us.
Are you saying this is some part of revision from grade 11?
No, from term 1. Term 1, grade 12.
So it's just a recap, mindsetters.
It's a recap.
Right, what are we doing?
We're talking about organic chemistry, and there's a new section in organic chemistry. Guys, if you go and look at past exam papers, you will not find any questions on this topic. Okay? It's called polymers. It's a brand new section, but don't be challenged by it. The exam guidelines are very clear that there's a limited number of things that you need to know. And we're going to try and go over all of those facts that you need to know for this section. And then the other thing to just be aware of is that together with organic chemistry, it's about 48 marks out of the 150 marks. So it's quite a big section when you combine it with organic chemistry. But I think that there's only going to be probably less than 10 marks on polymers in your final exam, if that.
Wow, still mindsetters, you need to focus on that. But to get this show started, you need to download your notes. They're all for free on learn.mindset.co.za. But now to also help you, we have this great innovation where you can just view the notes if you don't have a PDF viewer, or you can straightly download the notes. It is a direct link. I think
that's right. It's a website. We've taken the notes and posted it to a website so that you, if you only have a WAP-enabled phone and you've been battling to download, you can at least view them and you can work through the notes.
The same notes that you're going over.
Yeah, exactly.
How cool is that?
Yeah, it's we want you to do it ahead of time, guys. We'll try our very best to get notes up for next week as soon as possible, and then you'll get the chance to work through them before you come to the show.
Awesome. So always know where to get them. learn.mindset.co.za. Otherwise, follow us on Twitter at LearnExtra. And lastly, we have some cool things that are going to be happening on the show next week. Giveaways are on the way, so do look out for that one. We're giving away calculators, proudly sponsored by Casio. We like that, and we know that you're going to like that too. But for today, we're going to
Let's get on to polymers.
Yes.
So, guys, with polymers, we're going to first of all go through the main thing. And that is, we're going to identify and name polymers, define them, do some terminology. Then we're going to write some balanced equations for polymerization reactions. So there's nothing much new here. It's an application of organic reactions that you've done already. But they're really quite fun. And you'll find polymers everywhere, all around you. In fact, in your body, there are many polymers. Some of you are wearing clothing that is made up of a polymer. Have you heard of something called polyester?
Yes.
Polyester.
It's a certain fabric.
Yeah, it's a fabric. And you know what? It's a polymer. And what about polythene or polyethylene? Have you heard of polythene or polyethylene or polyethene? No.
No,
But
I've
you
heard
know
of
what?
polystyrene, rather.
You've seen it. It's what you find in those plastic bags. Plastic bags you go shopping with.
Mm-hmm.
That's polythene. Syringes,
Okay.
squeeze bottles. These are all polymer, examples of polymers. And so, guys, you need to be aware of them. They have an environmental impact. Some of them are biodegradable. How cool is that? A plastic that is biodegradable. And we can use them all over. You know what? I think that apart from learning all this theory, it would be really good if we could make a polymer. Seeing it's your birthday, let's do something fun.
During the ad break.
No, not during the ad break. We're going to make something fun.
Okay.
So what I'm going to do is I'm going to go over to the lab bench. I'm going to just ask you to stay there for a minute, and then once I've got the product, I'm going to ask you to come and hold it, and you can play with it.
All
Okay.
right.
So let's go and have a look. And I'm over here, and I've got a few little things. I've got a beaker full of warm water, and then I've got some stuff here, which I'm not going to tell you because it's poisonous, what it's called, but it's available, and I might give it away at the end, but I really don't want anybody to hurt themselves. So I'm struggling to...
You're giving it away as what, John? I hope it's not drugs
No,
and not. My
I'm going to
birthday
just put a
present.
little bit of this stuff in. I'll give you a clue to what that is. It's got a compound, an element in it called boron. Okay? And boron has got some very interesting properties. It's quite similar in some ways to carbon because it's kind of between the metals and the non-metals. So I'm just stirring this boron mixture up here, and I'm using warm water to make sure it all dissolves. So it looks like it's mainly dissolved. Because it's Abi's birthday, I'm going to put some coloring in it. and so I've just got some food coloring here, and seeing he's always wearing blue, I decided to put a drop of blue food coloring in, and now let's just swirl it so we can get that mixture looking really nice, a nice blue solution forming here. And now the next thing I'm going to do is I'm going to take from this container here some wood glue. Now, I'm just going to hold it like this. This wood glue has a polymer in it. It's called polyvinyl acetate, or PVA. But I'm going to stir this, and I'm going to add it to this mixture that's got the boron in it, and hopefully we can get some strands of stuff forming and see if it will start to react. And it's mixing up. I'm going to give it a stir just now. Okay, let's just keep it stirring. If we had a nice stirrer, it would... Okay, so I'm stirring it away, and as I'm stirring it, it's reacting. It will take a few seconds, a few minutes at least, because we want it to all mix nicely together. And what have I got here? Stuck to the end of that. It's not just the glue, I promise you. It has reacted with the boron, and if you look carefully, it's formed a kind of interesting stuff. Okay, Abram, you can come and have a look here.
And the smell, John.
No, there's not much smell. Okay. you see it's not the glue anymore, but it's got stretchy, okay? I probably have rushed it. There is some glue that's unreacted there. So let me put it back in, and because I can see that's the difference. The glue is the stuff that's on my fingers, and I just want to work it in so it reacts with the boron mixture. And I'm going to give you that to play with, because this is sticky putty or slime. Okay, but you can feel if you work it in, it just needs some more working. You can stretch it, and it's made like a...
So you can use this as a press stick.
No, not as a press stick. It's some people, this is homemade sticky putty, and you can play with it.
Okay.
Okay. So
Actually, I can build a
stretch
car
it.
or something.
No. Not that adventurous. Now, seeing I've got all muck on my hands, I'm going to move across to the board again, while you go and enjoy yourself playing.
It gets thicker and thicker.
It does get thicker. Work it, and at the end of the show, we'll have a look at how it's going.
Okay.
Okay. So you just work away with it. I'm looking for something to wipe my hands on.
Okay.
I think I've got something. I'm just going to use this cardboard, and then we'll go over to the board. So let me go past you, or you go past me, and you're going to need to get back to your place. And guys, let's get together with the notes on the board. Let's revise some terminology, because hopefully you've done this, and we'll go to the next page. So, you know what I forgot? Abram, I forgot the challenge question. So we went straight into all that detail about making slime or sticky putty, and it's really quite cool stuff. It's gone to be something more than it was. It was glue that was liquid, and now it's kind of a mush that Abram's still playing with over there, using on the ball. Here's your challenge question. It tells us the following. The monomer chloroethene, also called vinyl chloride, polymerizes to form the polymer polychloroethene, also called polyvinyl chloride, or PVC. I'm sure you've heard of PVC. Your PVC pipes that you get in plumbing. And it does this by means of an addition polymerization reaction. Now, guys, you don't really need to know that it's addition polymerization. There's only one polymer that you need to know that forms addition polymerization, or you need to know the detail. You need to know that this one does do addition polymerization, but you don't need to know the detail. So we'll make very sure of that. What it asks you to do is to draw the structure of the polymer showing two units that repeat. And to make your life even easier, what I've done on the board here is I've drawn for you the monomer. And the monomer was chloroethene. So there's the chloro attached to ethene, two carbons with a double bond joined together. Okay, that's your challenge question. It's posted on the Facebook page already, but let's get seeing how many of you can draw the polymer with two repeating units. Okay, moving on. Here are some definitions that you need to know. You need to know what is a macromolecule. Well, we've just made a macromolecule. It's the putty stuff that we've just made. It's a very large molecule of things joined together. There are it consists of a large number of atoms. Another example of a macromolecule would be a lipid or a protein molecule. Okay? Even the DNA molecule would be considered to be a macromolecule because it's so complex. It's got many atoms in it. Now, a polymer is a large molecule composed of smaller monomer units that are covalently bonded to each other in a repeating pattern. So we take a basic thing that's bonded covalently and we repeat it. one of the easiest representations that I've had of this is if you take some paper clips and then you join the paper clips together to make a long chain. That's exactly what you've got here. A monomer then is a smaller molecule that can be covalently bonded to others in a repeating fashion. Polymerization is a chemical reaction in which monomers join to form a polymer. Last thing that I need to just go through, because I don't want to lose this. There are two types of reactions: addition polymerization. And addition is where we break a double bond to make the single things happen. An addition polymer has been formed when you break the double bond. And then condensation polymerization is when two monomers with different functional groups. Remember what a functional group is? It's the thing that gives the organic molecule its property, like the alcohol or the carboxylic acid. And when those two different functional groups join together, usually with the loss of a small molecule, which is sometimes water, then you get condensation polymerization. Okay, guys, we'll come back to this. If I've gone too fast, get the notes. Abby, you've posted the link on the page for the notes.
Yes.
Make sure you read them. Make sure you learn them. This stuff is very important. You must know it.
And the challenge question also is posted.
Challenge questions posted. Having fun there with your putty.
Yeah, I am. Just wanted to see what I can make, but
it's quite stretchy, hey?
Yeah.
It
gets
and it's getting thicker
and thicker, yeah.
But it joins together and it's quite cool.
But it's more like a rubber now.
Yeah. Well, you know what? Strangely enough, some rubbers are polymers.
Oh.
Okay. So that's what we're dealing with. Some of them, that's exactly what it is. And that's what we need to understand. Okay. Abram, take us to a break.
Right, Manchesters, we'll see you after this break. Make sure that you still send us your questions. Welcome back, Mindsetters. Now, for most of you, like Chiamo Mulefe, who says that at a school, she doesn't have a physical science teacher, make sure that you go to our help desk. We're here to help you. We're always here for you, Mindsetters. Download our notes on learn.mindset.co.za, and I know that having teachers like John, you'll never be left behind.
Thank you, Abram. And guys, put in the effort. Even if you've got a teacher, you're not going to succeed in this subject unless you do some work for yourself. So get yourself the notes, get yourself a good textbook, and work through it until you understand it. Make sure you form yourself a study group if you need to. Get a friend together, go and work through the previous exam paper questions. When it comes to questions, the sections like this, make sure you try and find as many as possible. And we'll certainly include some in our exam revision that's coming up. So don't make sure that you don't make plans to go away. Matrics, it's time to work. Holiday time is over. So make sure that you're focused. You get ready for the June exams because they count towards your final exams. And it's good practice. Habits you pick up in June, habits you pick up in prelims, they're going to be habits that you're going to establish for when you write your final exams. If you goof out now and you don't prepare well, you're probably going to find it harder to work at the end of the year. Okay.
So true, John. Just to reiterate on that, the timetable is already out for the final. So the Mindsetters can also get the past exam papers to help them.
Just remember that in many subjects there are some slight changes. So, for example, because they're writing a CAPS they're writing the CAPS curriculum, there will be an exemplar out quite soon. And we'll make sure that those are available so that you can practice those. We'll work through those as well. Okay, so let's get into this question now. We're going as much in depth as we can for polymers. I don't think you're going to see very many difficult questions in polymers, but here is one that could possibly come up. It tells us that polyethene. Now, polyethene is an addition polymer. That tells you that it was made by addition. Let's remind ourselves what we mean by addition. And if you go back to your simple organic chemistry that we did last term, if we were to add hydrogen to that, what do? We break the double bond and we get this substance forming. So this was ethene, and we added hydrogen and we got ethane. The double bond broke and we made a new molecule, ethane. Now, in this case, it tells us that we didn't just make ethane, we made polyethene. Now, here's the trick, guys. You have to identify the monomer. The monomer is the starting block, the thing that has the double bond in it, because it's going to be broken to make the addition polymer. And that's where it becomes a little confusing, because the polymer in its name actually has the name of the monomer. So that's the monomer there. The monomer is ethene. Okay? Please note that the polymer, polyethene, is saturated. It doesn't have double bonds. So ethene is the monomer, and it looks like this one that I've just drawn up at the top. But now we're going to see what happens to that double bond. We don't add a carbon or a hydrogen to it or a chlorine to it. We simply add those monomers to each other, and so do the reverse process of cracking. Remember, with cracking, like from crude oil, we broke things apart into smaller molecules by the process of elimination. This is the reverse process. We're starting with the monomer and we're making a bigger substance. Just one other point here that I want to make, and I don't want to forget it, so I'm going to say it to you now. This is sometimes called polyethylene, and it can also be called polythene. Okay, it's the same stuff. It's your clear plastic bags, and we'll obviously add to that. There's some other stuff that it can be. It now says draw the structural formula of polyethene showing 3 repeating units. Now, I'm going to switch back over here and say to you, if I had another one of these, and I'm just going to do 2 for the moment, because I want you to see what happens. Look what can possibly happen. If I break this double bond, and I'm going to use the smallest little arrow over there, carbon has to have 4 bonds. I'm going to break that double bond there as well. Open it up. I'm now going to place it into that position. Oh, let's not do that one there. I'm going to place that one into that position, which is half the bond, and that one into that position. And now notice what happens on this side. That one can go into that position, and that one can go into that position. Now I hope you can see that what's going to happen is that these are going to join up. And now we get a realignment. And what have I got? I've got 2 H2C, 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 H2C. What are my units? What are my repeating units? It was this thing that was my original monomer is now repeated. And I've been asked to draw 3 repeating units. So I'm going to draw that one. And I'm going to draw the next one in a different color so you can see that it's 3 repeating units. In a way, it's just like H2, CH2 repeated infinite number of times. But that's the way we would draw it to show that it's this thing that's repeated. And where did it come from? It came from the thing that had the double bond in it. It had the ene in it. So if we want to go backwards, we look at this. We must break the double bond, put the double bond back in place if we want to get what the monomer was. One last thing here, AB. I've asked you to draw the 3 repeating units. Obviously, it can carry on for hundreds and thousands of those repeating units. So, guys, don't think that these are just small molecules. There is another way that we can simplify this representation. We can say, put the repeating unit into a square bracket, like that, and say to ourselves, we want n of those. And the n stands for a very large number. Different types of polyethene exist. You can get low density, high density, you can get them made for different purposes, depending on how the chemists want to make them. Okay, so they've got all sorts of uses, and we can show them like that. Now, the next question, which is a key question, it says to us, illustrate the reaction to produce polyethene. So I'm going to say to you, this is how I would illustrate it. I'm going to say, I'm going to start with my monomer, which is ethene, and I'm going to say I've got n of those. However many n is, 50, 100, 50,000, 250 million, it doesn't matter how many we've got. We're going to say we're going to undergo polymerization. And what do we get? We get the thing that I've just drawn up there. We can draw it like this. And say we've got n of those. They've joined together addition. They've broken the double bond. Okay. The last question here was for us to name 3 industrial uses. Now, guys, there are literally many. There are thousands of them. The one thing that you could say is they're used to make squeeze bottles. Now, if the bottle was too tight, you couldn't squeeze it. You couldn't get your juice out. Okay? So it needs to have a certain amount of flexibility. It's also used as insulation along wires, but it's also used for things like clear bags, clear plastic, what we know as clear plastic. And you could even go as far as saying bags. It's not the stiff plastic. It's not the stuff that you find in your cool drink bottles. It's a different type of stuff. They are related, but it's also a polymer that makes that. But there are some examples. You can also find them in syringes. So make sure you refer to your textbook. You could possibly get asked on the uses of polyethene or polyethylene or polythene. All the same name for the same stuff. By the way, this word that we use, polyethene, when we're naming polymers, is not strictly an IUPAC name. And so we aren't required to learn the IUPAC names, but just so that you know, it's not a strictly IUPAC name. Okay, let's do one other, and this is another very important polymer that you need to go through. Remember the first one that we've dealt with, we said was by addition polymerization. And you have to know the reaction, that question that I've gone through. You have to know polyethene. The second one tells us we're dealing with polylactic acid. Doesn't sound much like a polymer, but it is. It's an example of a polyester that's formed by condensation. Different process. You have to know this example. So you are beginning to see, if you look at the exam guidelines, you look at the CAPS document, you're probably either going to get asked on this one or the previous question. Let's make sure we know how to do it. So it says, first of all, draw the structural formula of the monomer used to produce polylactic acid. Now, Abram, what does poly mean? We asked, you tell me.
Poly means many.
Many. Okay? So many lactic acid. So in the same way as we did previously, we need to understand that polyethene, the monomer, was ethene. So if I said polyvinyl chloride, then I would say the monomer is vinyl chloride. Polystyrene, we'll get to that. The monomer would be styrene. But in this case, we're asked to draw the structural formula of the monomer. The monomer is going to be lactic acid. Now, lactic acid is a stuff that is produced in our bodies. It's produced in organic lactic acid. Okay? It's produced naturally and it ferments. Here it is. What you need to notice about this lactic acid is it has a carboxylic acid functional group on the one end of the molecule, and it has an alcohol functional group on the other end. Now, that is very significant. So we've got two functional groups on the same molecule. Notice it gets the name lactic acid, and even the polymer is called polylactic acid because it's coming from this. So the next part of the question, we've identified lactic acid as the monomer. Notice that it is quite a simple molecule. It's C3, and we've got H. How many H's are there? There are 3, 4, 5, 6, and 2 oxygens. 1, 2, 3 oxygens. Okay, so it has a simple molecular formula, but its structural formula is more complex. Now, the next thing says to us that we're asked to illustrate the reaction produced by, illustrate the reaction to produce polylactic acid by showing how two monomers combined. Now, I could take the easy route out, and I could draw the monomer and then just put a bracket around it and say N of those produces the polymer. I'm not going to do that. I want to explain it to you because I want you to see why this is a condensation reaction. So I'm going to borrow some stuff from that first question, and hopefully it will work. Let's see if we can get it to work. I'm going to copy this. I don't want to paste. I want to copy. And now I want to paste. I'm going to paste it over there. Voila. And I'll paste again and say paste. Now, guys, here we go. Have a look. Remember I said to you that we've got a functional group over here, which is a carboxylic acid. And on this side, we've got a functional group that is an alcohol. On that side is alcohol, and on this side is the carboxylic acid. Now, what do you know happens when we combined an alcohol and a carboxylic acid? Think about it. You've done this before, and I know that you can do it. Because what you should be able to see is that if we eliminate that, what have we eliminated? We've eliminated an OH and an H. Guys, OH and H will give me H2O. If I were to draw it, I would draw it like that in its structural form. Okay? Taking out the water, what am I left with? Notice something here. That's gone. So that's gone. I've got a linkage between CO, there's my CO, and it's linked to a COO on this side. That reminds me of an ester. And it should remind you of an ester. So if I were to do this, and I don't want to waste time, but I want you to see that there's my linkage. It's formed a linkage over there, and it's formed a linkage over there, which will carry on to the next one. And on this side, it will form a linkage, which will go to that one and the methyl group down here. And there's my hydrogen, there's my oxygen, and there's my linkage. So I hope you can see that I've just cut off the ends of those ones, and I've cut off the end on this one. But in the between part, what have I got? I've got this part here that was from one molecule up to that point. That was one molecule. It's combined with the second molecule, and there we've got it. It's formed this ester bond, and that's your polylactic acid. Hope you've got it. Make sure you understand it. It's very important because this type of plastic is biodegradable. We've got to be making more of this and less of the other stuff to save our environment. Abram, I think we've come to the time up for a break. There is one more question, but let's see if we can do the challenge question after the break. And if there's time, we'll get back to this one.
No problem, John. Mindsetters, if you're struggling anywhere, send your questions through on facebook.com/LearnExtra. Otherwise, just click on the button where it says click on Facebook for the help desk. We have an app that is working on Facebook, so go check it out. We have FAQs there, and also you can send us your own questions. We'll see you after this break. Welcome back, Mindsetters. Now, to help you through next week, we have a competition. We know that some of you don't have calculators, so Keisha is giving us some calculators for next week. So do look out for that competition. It's exciting. All you need to do will be to download your notes and check the test yourself questions, but more details are coming next week.
Absolutely. Guys, the test yourself are there for you. Don't miss this week's test yourself because they will help you prepare for your class tests, help you prepare for the June exams. Make sure you do them. Right, what about the challenge question? Have we got any answers?
I have so many answers and questions and comments, rather. Some people say, as much as I would want to answer, I can't. First encounter, I'm failing.
Okay, let's fix that. Because we don't want anybody that's watching this show and that's putting in the effort. There's no reason for you to fail, guys. You just have to take the steps and follow them through. You'll see how easy it is because they can't really ask you anything much more than what I've put on the board and in the notes. Okay? It's very clear. This section will not give you difficulty if you get it right in your head.
So true, but on a positive note, we have some answers. Some Mindsetters posted their pictures.
Okay, excellent. So let's make sure that we follow it through. Now, it tells us what the monomer is. It tells us the monomer is chloroethene. Okay? And they've even drawn it for us. And what they want us to do is draw the structure of the polymer showing 2 units. So guys, what I'm going to do is I'm going to take that monomer and I recognize that PVC is made by means of an addition polymerization. When I hear the word addition, it means break the double bond. Okay? So what am I going to do? To draw the 2 repeating units, I'm going to say I need 2 of these things. There were 2 carbons in that, so I'm going to draw the 2 carbons with the hydrogen, with the other hydrogen, and with the chlorine. And I'm going to draw a second one in a different color, and I suggest you do the same. We're taking the monomer and we're repeating it. And it's just like doing a stamp. Do you remember in primary school, in kindergarten, you made potato stamps?
Yes.
And you put down the stamp, and then you put it down next to it, and you put it down next to it. And then you made that line of patterns. And if you made your potato stamps carefully, they made a nice long pattern.
Yes.
And they all fitted together. Okay? Same thing here. So guys, we're just doing potato stamps, but with organic molecules. Now, remember the monomer had a double bond in it. We said, let's get rid of the double bond And let's make sure that that one and that one join together. The other half goes on that end, and the other half goes on that end. So what have we got? There is your polyvinyl chloride with 2 repeating units. Remember, we could summarize that as simply to say CC, Cl on this one, and then H over here, H over here. If they didn't ask us for the 2 repeating units, then we could make it in a simpler form. We could do it like that to say we want n of those, where n could be any number. Okay. People get it right?
I saw some right answers, and I
Okay.
think it's one of the pictures.
Okay, excellent. So guys, please don't get panicked with these names. Please understand that the monomer is in the name of the polymer. Okay? And so we can get it very easily. Let's go back very quickly, because I think it's important that we get it right, to question 3. It says, identify the monomers. Now guys, this is a question that you could get. The 2 questions that I can almost guarantee you. You're going to get asked one of the reactions of polyethene or of polylactic acid, to illustrate it like we did question 1 and 2. The second type of question you're going to get asked is identify a monomer. And what's the monomer of polyvinyl chloride? Well, we've just done it. You could write the answer as vinyl chloride. They cannot mark you wrong for that. Or you could say that it is, what did we have in our challenge question? If you look, we gave the name chloroethene. So if we go back over here, we can say it is chloroethene. Okay, that's the monomer. Now, if you go to this one, polystyrene. What's the monomer? Oh, guys, it's like falling off a block. Styrene. Now, what does styrene look like? If you look in the test yourself questions, there's an example of styrene. And I don't want to try and remember it because I've forgotten it already. I know it has an aromatic ring in it. Okay, so it has this sort of ring, which is a benzene ring, and they do that, and it's got some other things attached to it. But this is the benzene ring that is part of styrene. So you can remember, if they give you the diagram, the one that's got the benzene ring is probably the styrene, because they've limited the number that you need to know. Polyethene, what's the monomer? Polyethene. Notice, they've dropped the H. So what are we going to say? It's ethene. And we've done that enough times. And then polyvinyl acetate, well, it's vinyl acetate, which is the glue stuff that we use to make our stuff that we've got there. Abram, let's see that ball of stuff that you've been working with. I know it's got into a
Actually
boot.
made a boot.
You made a boot for
Yeah.
walking together, hey?
Yeah.
Okay, so let's do some walking together now. Give me some questions.
Cool, John. First question. Tony, tell me, what is the function of H2SO4?
Okay, guys, let's be very clear about this. Sulfuric acid is one of the most important organic substances, H2SO4. It's used in many different situations. In organic chemistry, specifically in esterification, in making of esters, it's used as a dehydrating agent. And we also say it is a catalyst. Now, as far as I know, most polymers are made, even the condensation polymers don't require sulfuric acid, consulfuric acid. It's concentrated sulfuric acid that's used in esterification. Must be concentrated. But you will learn later in the year that sulfuric acid, H2SO4, is used in the production of fertilizers. It's used to make fertilizers and the products of fertilizer. It's used to make phosphoric acid. It's used in batteries as the acid in the batteries. So it has many uses. In fact, it's often referred to as the king of inorganic chemicals because there are so many things. You can tell the state of a country's chemical industry by looking at the consumption of sulfuric acid. It's a very important substance.
Awesome, John. Here's another question, Mpumelelo. What is the difference between hexane and the compound in question 1B?
Okay, hexane. Okay, hexane, very good question. And the polymer that we looked at was polyethylene. Now, please notice something. Hexane has the formula C6H14. If we tried to draw it, you'd have to draw in all the six. I'm not going to do it, but you'd have C3 on the end, and then it would be CH2, and that would be repeated how many times? We want that 4 times, and then we go CH3. Okay, so if you count 4 of those, and one of those is 5, and one of those is 6. Now, I only drew 3 repeating units of my previous one, of the polyethylene. So if I was to say what's the difference, well, there's a huge difference, because I was only looking at a small portion of the polyethylene. Remember, the polyethylene can be millions, even as many as 250 million. Okay? So we said that it's that with an N on it. This one stops. It's limited. It's only got 6. This can have multiple amounts of carbon. Okay?
Unfortunately, we have to end it there.
Guys, I'm sorry, but it's been great being with you. Have a great week, and we'll see you next time.
Awesome. Thank you so much, Mindsetters. Remember, if you missed the show after 2 days, you can catch it on YouTube. Go to www.youtube.com/mindsetlearn. We love helping you like that. But for today, we just want to say all the best with your new term as you're beginning. Keep up the attitude and keep on believing in yourself. We love you, and peace.